Interest in using Asterisk. People are connecting to carrier networks that want voice codecs that they don't have on their phones, for example, or can't support on their phones, or they're interconnecting multiple carrier networks together. So because Asterisk is, we like to say it's protocol agnostic, we speak every voice over IP protocol that there is, basically, that has any traction in the industry at all. And then, of course, we also speak TDM protocols, PRI and SS7 is coming in the next version and things like that. We also support basically every voice codec that we can. Now that list, I think that list is actually complete for what we support in Asterisk today. It's missing a lot of codecs, though. The reason it's missing a lot of codecs, though, is because all the cool ones that people are using now have about a stack of patents about this high behind them. And they're very, very difficult to implement, first of all, in an open source way without violating the patents. But even if you manage to get a non-patent infringing implementation of them, then all the users have to pay licenses to use them, and that's a very difficult thing to do for a piece of software that you just downloaded from the internet for free. So we're working on solutions for those, but those will generally revolve around cellular networks, cellular network codecs, because that's obviously a big area where people are connecting to cellular networks. And also now there's a big push to do wideband audio. I don't know how many of you have experienced the pleasure of listening to a wideband audio call, and especially a wideband audio conference, but it's really quite amazing. So someday we'll actually be free from the restrictions of the public telephone network, and you won't be limited to 4 kilohertz audio anymore. So this is an area where people use Asterisk. I guess you could call it sort of as a session border controller, although I hesitate to use that terminology because it doesn't do all the things that an SBC does. But it can certainly be used as an edge device to connect multiple networks together, change voice formats between them, and even do protocol conversion. So we have people out there who may be providing, maybe they're like a tier 3 voice over IP carrier, and they're buying minutes from lots of different carriers around the world, and they may find a really awesome carrier in some country that only does H323, and the rest of their network is SIP. Okay, well they'll put a group of Asterisk servers sitting in between their network and that carrier and say, okay, we're going to do protocol conversion between the two. So this is actually something that's relatively easy to set up in a clustered environment because you have total control over everything going in and out. It's not like you have wild stuff just happening in this area. But all right, and then of course there's the big stuff that people want to do, which is to actually use Asterisk as a voice switching platform, and in some cases as a video switching platform, because we support video media streams as well. So there's basically 3 big areas that most people are using clustering to accomplish, and this is really the most common one. And that is that they've reached the point where one server can't do the job anymore. They just don't have enough performance to do the job. As I mentioned before, there's no built-in load balancing functionality inside Asterisk, and we don't really see any reason to build any because there's excellent external products to do that. In the case of SIP, that's OpenSIR. In the case of, say, TDM connectivity, maybe you have a large group of PRIs from your telephone company, or you have SS7 trunking. That's going to be done on the switch that services you. They're going to figure out which trunks to send calls to based on which ones they're busy. But the point here is because of the way Asterisk is architected, it's extremely simple to say, well, I don't want to just have one of these, I want to have 6, and I want to have them all act exactly the same way. The dial plan is extremely easy to share between servers, and for those of you who haven't used Asterisk, there weren't very many hands, so I don't know how many people that is. Pretty much everybody else has. Unlike, say, traditional voice switching platforms where you used some arcane interface to build these massive translation tables of incoming numbers to outgoing numbers and things that you could do to that, the call routing in Asterisk is very much like, I would say it's almost like a programming language, but it's a very simple one. It's very scripting oriented, which means that once you've developed a dial plan that does what you need, it's very easy to replicate it to other servers and have everything act the same way. And then we have multiple methods of actually monitoring the servers to make sure that you can actually balance the traffic between them. And if you want to take a server offline, do so and have the load balancer stop sending calls there. One of those, again, is that management interface that I mentioned before. And then we also have support for SNMP for those of you who have large networks of routers and switches and other things that you manage with SNMP and want to watch statistics of. you can do so using an Asterisk now as well. Make sure I'm not running out of time here. This, of course, is the second big reason why people want to cluster Asterisk servers, and that is that they're concerned about failures of some kind, whether it's a software failure or a hardware failure, or even just the ability to take the system offline to be able to do an upgrade or a change in configuration. They want to be able to have all their traffic still survive. Again, the first step there is to set up some sort of load balancer so that the calls are being distributed among the cluster of Asterisk servers. But the second part is the important one, and that is you've got to figure out a way to share all the information between the servers so that they all know what's happening at all times. For example, a lot of smaller ITSPs are using Asterisk to provide service to small businesses, and they may have sold that small business a trunking package that only allows them 5 simultaneous calls, for example. Even though we know there's not 5 physical trunks associated with that, they've sold it to them that way. Well, if they have a cluster of 20 Asterisk servers providing that service, then there has to be a way for all of those servers to communicate with each other to know that there's one call active on this server and 2 on that one and 1 on this one, and if they try to place 2 more, they won't be able to do that. So we have methods for doing that already. I mentioned some of them before, being able to store information in databases. And then I'm also going to show you another slide, protocols that we have that are built into Asterisk already for helping to do these sorts of things. But one of the interesting points here, unlike most, I'll say commercial products again, packaged products, is there's no special knowledge, no special protocols you have to support or special links you have to set up between the servers or any of that to make this stuff work. It all uses the things that you're already familiar with if you're familiar with using Asterisk in the first place. And then finally, the last reason, of course, that people do clustering is for literally failover, hardware failure problems that they need to deal with. As I mentioned before, Asterisk was originally designed to be a PBX, a small business PBX for that matter. In a small business, if the phone system crashes and is unavailable for a minute, okay, you'll just deal with that. If you are an enterprise servicing 5,000 users, that's probably not really something that you want to have to deal with on any sort of regular basis, and you don't want to have it crash and have someone go spend 2 hours trying to bring it back up. But what that resulted in, that design decision that was made very early on in the process, is that we don't currently have a way to have 2 operating Asterisk servers be completely parallel to each other and handling everything exactly the same, so that if something happens to one, the users don't even notice that there's a problem at all. We wish we could do that. We have it all written on our whiteboards that we want to be able to do this someday, but it's an enormous undertaking to do this. And in actuality, there's very few products out there in the marketplace that even do this at all. Even most large carrier-grade existing telephone switches just put in lots and lots and lots of redundancy to solve this problem. They don't have 2 completely independent switching platforms handling the calls in parallel so that one can take over for the other. So, with all that said, I don't want to be too negative there, what most people want is that if there is a failure, they understand that the calls that were being handled by that particular node in the cluster are going to be lost. They want to be able to have that user pick up the phone and press the redial button and have the call go immediately through. Now, having a cluster in the first place, of course, is going to help that problem, because when you push that redial button and the call gets to your load balancer, it's going to know that the server that's down is down and send the call somewhere else. But there are still cases where you have servers within the cluster that are unique in some way. And we, as an example, one of the things that's becoming very common now is to provide hosted Centrex, but IP Centrex, so it's all done with IP phones at the client site instead of traditional phones. But now you've actually got a box at the data center that is acting as the PBX for that company. It might also be acting as a PBX for 25 other companies, but it's not just one massive platform doing this. And if that box fails, you need another one to take over for it really, really quickly.